Okay, so here's two law of cosines examples, and I just want to remind you that if there's an opposite pair, meaning an angle on the side opposite, we would use law of sines, but that is not going to happen in these examples. Okay, so in this first one, we are being asked to find the largest angle of a triangle when we're given three sides. So the very first thing we're going to do, as I've mentioned before, is we're going to draw the triangle. So we're just going to draw and label our triangle, and I'm going to decide this is A, this is B, and this is C. And then remember, opposite angle A is going to be side A. So this is where little a is. So little a equals 8 feet. And we know that opposite angle B is side B. So little b is 14 feet. And then we know opposite angle C is side C. And so little c is 19 feet. Now I have no opposite pairs. I only know the three sides. So what I have to do is find an angle. And since it asks for the largest angle, we know that the largest angle is the one opposite the largest side. So we are looking for angle C, which is of course good news for me because that means I can sing. Woke up on the right side of the bed. What's up with this math song inside my head? Hands up if you're down to get math today, 'cause it's a law of cosines. Rushed into my class like I didn't care. Hopped into my seat so I'd be prepared. I'm in if you're down to learn math today, 'cause it's the law of cosines. Cosine of C is A squared plus B squared minus C squared, all divided by 2AB. It's the law of cosines. And that's good enough for now. So what we're going to do now is plug in the numbers. So we know that this is 8, this one is 14, and this one's 19, and of course they all have their little squares. And now it is extremely important that we remember the parentheses when we plug this into our calculator, because we want to make sure that the calculator knows who belongs in the numerator and who belongs in the denominator. Okay, so be very careful how you plug that in. And if you do it correctly, we find out that cosine of C equals negative 0.45 and a whole bunch of other numbers. But we know that's not our answer. Right, of course not, because that says cosine of C equals that. So if I want to know what the actual angle is, I have to do the inverse. So C is cosine's inverse, or cosine to the -1, of my answer. And when I get that in my calculator, make sure you're in degrees, we get 116.80 degrees, and that's our answer. Okay, so for this problem, we have a bearing problem. We have a plane that's flying 810 miles from town A to town B, and we're told the bearing that he is flying is north 15 degrees west. Then there's a second plane who's flying 648 miles from town A to town C, and his bearing is north 70 degrees east. And we're asked to find the distance between town B and town C. So the airport is clearly in town A, so we are going to start by drawing a picture. And the picture that we're going to draw is just a reminder that we have a compass, right? And north is always here on the top. So let's just get that out of the way for now. And let's draw the first plane. So he's traveling 810 miles north 15 degrees west. So if this is my compass, then I go from the north towards the west 15 degrees. So it's really hard to draw that, but do the best you can and know that that right there is 15 degrees. Okay? Now we also know that he is traveling 810 miles. So I'm just going to label this as 810 miles. Okay, so now the second plane is traveling only 648 miles at a bearing of north 70 degrees east. So once again, if this is my north, over here is my east, so we're leaning 70 degrees in the east direction, and he's only going for 648 miles, so that line should be a little bit smaller. Here's where town C is. I should have labeled this one as town B, and of course this is town A where we started. And the question that they're asking me is, what is the distance between these two towns, or little a? Okay, so be careful. We know in here from the north line, from my north line, 15 degrees is right here, and I did try to write it in and then thought better of it with the 70. This side from the north is 70 degrees, so that means this whole angle is 70 plus 15, or 85 degrees. And now when you're looking at this, we have a side, I don't know the angle. I have another side, I don't know the angle. I have an angle, and I don't know the side. So this one is side, angle, side. It does not give me an opposite pair, which means I have to use the law of cosines. This time we're using the standard form, which is the one we don't have a song for, but it's all good. So we know that a squared equals b squared plus c squared minus 2bc times cosine of angle A. Okay, so now we're just going to plug in all those numbers, which I've gone ahead and done. So 810 squared plus 648 squared minus 2 times 810 times 648 times cosine of 85 degrees. And what I'd like you to practice doing is plug it into your calculator from the 810 all the way to the cosine of 85 degrees. Don't do this in pieces. Use that fancy calculator that we're using to get our answer. Any scientific calculator will do this from the left-hand side all the way to the right-hand side of this side of the equation. So from that 810 to the cosine of 85, and once you do that, we find out, and I'm just going to scooch over a little here, we find out that a squared equals 984,511.3875. That's a great answer, but compared to my other answers, 648 and 810, that's huge. And that can't make any sense to you, but of course if you check carefully, it says a squared. So what I need to do is take the square root of both sides, and then we find out that a is 992.23 miles long, and that's the distance between town between town B and C. And there's our practice for law of cosines, so now you should be good to do your homework problems.